everyone. So today we're going to talk about what is statistics. So the first thing we're going to talk about is what is statistics. So statistics is the study of how to collect, organize, and analyze and interpret data collected from a group. So there are two branches of statistics we call the first one descriptive, and the second one is inferential. Now, descriptive statistics is where you collect and organize data. This is going to be the sort of first half of the class. And the second portion we'll look at inferential statistics, which is where you analyze and interpret the data. So the first thing to decide in a statistical study is to whom you want to measure and what you want to measure. So we can look at an individual, which is a person or object that you are interested in analyzing, and the other thing is the variable, which is the measurement or observation of the individual. If you put the individual and the variable into one statement, then you obtain a population. Now, my population, the formal definition is it's the entire group of objects or individuals of interest in a statistical study. Now, we can't always look at the full population. So what do? We look then at a sample. And so a sample is just a part of the population or a subset from the population. And this is a lot easier to do. It's easier to gather, and usually it's less expensive to do. So things that come from a population, a numerical calculated from the population, we call this a parameter. And it's usually denoted with a Greek letter. Now, if it comes from a sample, it's a number calculated from the sample, we call it a statistic. And you'll notice that there's no S on this. So we have statistics, which is, the whole general idea, and a statistic is a number calculated from the sample. So it's usually denoted with letters from the Latin alphabet. It is used to estimate the parameter value. So what I always like to remember is it's a population parameter or a sample statistic. That's how I sort of remember it. So let's take a look at our first example, sort of with all of these different things and how we can address them. So example 1 says, given the following scenario, identify the individual, variable, population, sample, parameter, and statistic. So it says a biologist wants to estimate the average height of a plant that is given a new plant food. She gives 10 plants the new plant food. So what we want to do is look at what the individual would be in this case, variable, population, sample, parameter, and statistic. So the individual in this case would be the plant that's given the new plant food. So we could say a plant given the new plant food. And so my variable, what are we measuring? We're measuring the height of the plant. So the height of the plant. And now it wants to know, what's the population versus what's the sample. So the population is sort of all. So it's the set of all plants given the new plant food. So it's the set of all plants given the new plant food. And so my sample, would be a subset of this. So we're looking at just 10 plants that were given the new plant food. So that would be my sample. It's the set of 10 plants given the new plant food. And so the last thing is it wants us to determine what would be the parameter, what's the numerical calculation from the population, and then versus the statistic, so the number calculated from the sample. So the parameter would be, we're looking, it has to do with the variable, the average height of all plants. Average height of all plants And the statistic, right, would just be what's calculated from the sample. So it's the average height of the 10 plants. So average height of the 10 plants. All right, so we can sort of designate what's the difference between what we're looking at from the population versus the sample. Second example. It says a political scientist surveys 28 of the current 117 representatives in a state Congress. What is the size of the sample and what is the size of the population? So what we want to look at here, right, we're given two numbers here. So we're given the 28 and the 117. So usually the sample is smaller than the population. So the size of the sample, it would be the 28, right? So it would be 28 representatives. And my population in this case would be the 117 representatives. And so if we know, again, a population doesn't have to be huge, it's just based off of what we're looking at. So in this case, our population was the number of representatives in this state's Congress, right? And then we sampled from there. So let's continue. So our next little piece is going to look at the different types of variables we could see. So it says we also have two different types of variables. Each type of variable has different parameters and statistics that you find. We even have different statistical tests that can be used with each. So the first one we're going to look at is what we call qualitative. So qualitative or categorical variable is an answer is a word or name that describes a quality of the individual. So maybe an eye color or hair color. So just to note, qualitative variables are sometimes a number, but in these cases, that number is used just to identify or categorize information, not used for its numerical value. So if the number could just be easily replaced with a letter or symbol, it is qualitative. So an example would be like a social security number or even a jersey number. Both of those are numbers, but a social security number is just a number, right? It doesn't really represent a true numerical idea. And even the jersey number, right? Usually those are just sort of given to different players. It doesn't really mean anything. So our last type is what we call quantitative. So quantitative, or a numerical variable, answer is a number, something that can be counted or measured from the individual. So this could be like age, weight, or even height. So let's take a look at example 2. It's going to want us to identify if the variable is qualitative or quantitative. So I look at a dog breed, right? So if I think of dog breeds, right, it could be Labradors, Golden Retrievers, Dobermans. So if I think about that, right, it sort of describes an individual. In this case, right, it describes a dog. It's not really a number. So in our case, a dog breed would be qualitative. So if I look at average rain per year in Arizona, right, this would be a number, maybe 1 inches, 2 inches, 2.5 inches, right, 10 inches. But the idea, it would represent, right, the number of inches that was fallen in Arizona per that year. So this would be quantitative. So C says the visitors Disneyland had in January 2020. Again, if I think, right, we could go to each of the days in January and it would have a number that entered Disneyland. So this would be quantitative. Now, if I look at the make model of cars, right, this could be Nissan, Chevy, GMC, Dodge. So they're not really numbers, right? It's just a word that describes, right, the type of car. So this would be qualitative. So now that we can identify what type of variables in the data is, so it's qualitative or quantitative, we can look closer at the two different types of quantitative variables. So the first one being, we call it discrete. And so it says data can only take on particular values like integers. Discrete data are usually things you can count, whole numbers, so there's no decimals or fractions. My other one is continuous. Now, continuous data can take on any value. Continuous data are usually things you measure. So we can represent it as an interval on a number line. So this could have decimals, fractions. It could also be whole numbers. So let's take a look at our example 3. So we want to classify the quantitative variable as discrete or continuous. So if I think the number of books in the GCC library, right? So I think there really can't be like a decimal or a whole number, right? There should be could be a whole number, but there's no really decimals, right? You wouldn't have 1.5 of a book. So it should just be whole numbers. And so we would say the number of books in the GCC library are discrete. Now, if I think of a speed of a car, right? We could be going 65.5 miles, 64.3 miles, right? So we could be going some type of decimal, right, of a speed. And so we would say this is continuous. We could represent the speed of a car on a number line. Now, what about the weight of a dog, right? If you think, could you have a decimal of weight? And you could, right? You could measure the weight of a dog, and it could be 50.5 pounds. So we would say this is continuous. If I look at the number of desks in a classroom, right, this would be a whole number. We would not have, a decimal of a desk. So in this case, the number of desks in a classroom, we would say is discrete. There we go, discrete. So, we could say there are 10 desks in the classroom. So that's a little bit between discrete and continuous. And based on whether it's discrete or continuous, we can do different things with the data. And we'll take a look at that a little bit later in this class. So once you collect your data, you need to determine how to organize it and what statistical tests to perform. The type of data that you've collected will, in part, determine how it should be organized and studied. So we have different level of measurements. We have 4 scales we're going to look at. So the first one is nominal. Data is just a number or category. There is no order to any data, and since there are no numbers, you cannot do any arithmetic on this level of data. Example of this are gender, car name, ethnicity, and race. You can just label them, but there's really nothing more you can do with the data. We then have ordinal. Ordinal, it's data that is nominal, but you can now put the data in order, since one value is more or less than another value. You cannot do arithmetic on this data, but you can now put data values in order. For example, you could have like letter grades, right? You could put them in order of A, B, C, D, or F, or place values in a race, or even the size of a drink. You then have interval data that is ordinal, but you can now subtract one value from another, and that subtraction makes sense. You can do arithmetic on this data, but only addition and subtraction. So examples of this are like temperature and time on a clock. And our last level of measurement is what we call ratio. So data that is interval, but you can now divide one value by another, and that ratio makes sense. You can now do all arithmetic on this data. So examples of this are height, weight, distance, and time. So usually the hardest thing is to determine, is the data at interval or ratio level of measurement. And so with that, we're going to look at one thing we can look at too to help us determine which level of measurement it's at. But just to note, nominal and ordinal data come from qualitative variables, and interval and ratio come from quantitative variables. So that can also help you sort of distinguish which one it is. So also to help determine if the data is at the interval or ratio level of measurement, we look at the 0 in the data. If the value of 0 means there is no measurement, so the idea of nothing, the 0 is an absolute 0. So it's at the ratio data. If there is no absolute 0, then the data are interval. This type of 0 is just a position on a scale. So an example of an absolute 0 is if you have $0 in your bank account, then you are without money. This would be an absolute 0, and the data would be at the ratio level of measurement. However, 0 degrees Fahrenheit is not the absence of temperature, rather it is a place on a scale making temperature at the interval level of measurement. So we'll take a look a little bit more in depth when we go through and do our examples. All right, so example 4. It says identify whether the data is qualitative or quantitative and then determine the level of measurement. So nominal, ordinal, interval, or ratio. So if I think of eye color, right? Eye color, right? Blue, green, brown, that would be qualitative data. And so since it's qualitative data, this means it can only be nominal or ordinal. So if I think of eye color, right, I list them all out. We want to think, is there a way to really order them that makes sense? And if I think of this, right, would blue eyes come before brown eyes or green eyes? Not really, right? There's really no way to order the eye color to make sense. And so we would say this is just at the nominal level. So now I have years of graduation, right? So maybe you graduated in 2020, or maybe you graduated in 1990, right? Whatever the case may be, right? So if I think of, is it qualitative or quantitative, right? It would represent quantitative data, right? It's numerical. So quantitative. And so now I think of an absolute 0, right? So I know probably no one graduated, right? Year in 0. But if I think of what does that 0 represent? Does that mean a lack of something, or is it just a position on a scale? And if I think of it, it's just a position on a scale, right? You could graduate before that or after that. Again, this is like a hypothetical question. So because it's just a position on a scale, it would be at the interval level. So the interval level of measurement. Now I look at average rainfall per year in Arizona. And we looked at this example already, and we had determined it's quantitative. So I have numerical data, so that means it either has to be at the interval or the ratio level. So let's think of this 0 again. So if I think of 0, right, if there was an average rainfall per year in Arizona of 0, is this a position on a scale, or does it mean nothing, right, or a lack of something? In this case, if we said 0 for the year in Arizona, it would mean that there would be no rain, right? There's a lack of something. So that means it is an absolute 0. And so we would say this data is at the ratio level of measurement. And so my last one, it's a movie rating. So, right, we have G, PG, you could have PG-13, you could have R. And so if I think of this type of data, this would be qualitative data. And if I think of, I can look at nominal, ordinal, and if I think of these movie ratings, is there a way to put them in order? And in this case, there is, right? We could say from most kid-friendly to, right, most violent, or vice versa, but there is a way to categorize them that makes sense. And so we would say this data is at the ordinal level of measurement. All right, so this is just a little bit about what is statistics, some common phrases that we hear throughout this course. And so we'll look a little bit more in depth of each of these pieces a little bit later on in the course.